Hi, I'm Samir Shende from the University of Oregon, and it's my pleasure to introduce Dr. Mike Heroux, who's a senior scientist at Sandia National Laboratories and the Director of Software Technologies for the US DOE Exascale Computing Project and scientist in residence at St. John's University, Minnesota, for the keynote talk this morning on E4S. Mike.
Thank you very much, Samir. Welcome, everybody. I'm very glad you were able to join us. It's a privilege to be able to talk about the work that we're doing and bringing collaborators throughout the day and people who are working on similar kinds of software efforts. We hope this day will be a good event for you. Thank you for attending. Before I get into E4S, I wanted to describe a little bit about the project that really enabled the kind of birth, if you will, of E4S and continues its ongoing growth and expansion into activities, and that's the Exascale project, U.S. Department of Energy's Exascale Computing Project. We have as a very explicit goal to create the software capabilities and application software capabilities for the exascale systems that are appearing in the not too distant future. Frontier at Oak Ridge, which is a Cray AMD system with AMD accelerators, and Aurora, that's a Cray Intel system with Intel accelerators. And then sometime later, El Capitan at Lawrence Livermore Lab, a similar system to what Frontier will be. And then, of course, there's Perlmutter, which is coming a little bit sooner, and at Lawrence Berkeley. And then our current systems, in particular Summit, which has at least an execution model that's very similar to what we're expecting on the exascale platforms, as a real workhorse for us. So these are the systems that we're targeting. Within ECP, the software technology area is the area that I lead and director of, is one of three focus areas. Application development is creating a collection of applications, roughly 25 or so, applications from a variety of scientific, engineering, and national security areas. And then hardware and integration as a collection of people who have deep understanding and deep connections within the DOE leadership computing facilities, who help the application and software teams make sure that our plans and our efforts are in line with what's going on at the facilities where our work is targeted to make the biggest impact. And by the way, if you have questions at all please mention them in the chat. I'll bring the chat window up and read the question and then take it. I'll try to leave some time at the end for questions. Okay, so within ECP software technology, we have 6 technical areas. And so myself and Lois McInnes are the director and deputy director. And then we have 6 very well-known, highly visible scientists in the DOE community leading the other areas. Programming models and runtimes, development tools, math libraries, data and viz, and then software ecosystem, which is our investment in tools like SPAC and the SDKs, packaging and container technologies that will help us in our delivery of capabilities to the users, to the facilities. And then NNSAST is a collection of the open source efforts at the National Nuclear Security Administration Labs, Sandia, Livermore, and Los Alamos. And there are a number of really important open source projects at these 3 labs that need to be engaging with the open and broader community. And so those projects receive funding and are held to the same kind of planning and accountability in terms of progress as the other projects in the other areas. So what do we work on? We work on a variety of things, many of the things that if you've been in the HPC community, know. We work on MPI capabilities, and we're not the owners of these tools. We're providing capabilities that are preparing this existing software base to be able to run well on the next generation of leadership computings. And in this case, in particular, It's running across multiple accelerated platforms. So you have a machine that has, host CPUs, multiple devices hanging off of those CPUs with physically discrete memory spaces and a lot of compute capability and memory bandwidth as well. And so we're preparing our software stack for this kind of architecture. Summit, as I said, is a similar architecture. What's really challenging and unique, and I think one of the great value propositions coming out of ECT, is a portable software stack, something that's able to run not only with CUDA on NVIDIA, but also on Intel and AMD accelerators. And then hopefully, a portability that would then be extensible to further heterogeneous platforms as we anticipate we will be moving to next generation systems that are not just multi-device homogeneously, same device, just a bunch of them, to heterogeneous devices, multiple devices of multiple types. And so we anticipate this kind of future for HPC. So as I said, MPI, in particular MPI-CH and OpenMPI, both are important products in the space. MPI-CH is, of course, the backbone for the exascale systems, but OpenMPI provides a lot of nice features and kind of forward-looking efforts in different areas. And then work in OpenMP and OpenACC, and I'll let you read through the list. I won't go through them all in detail, but I hope you can see from this list that we're not developing a whole brand new crop of capability of new products, brand new products. Instead, what we're developing is new capabilities within existing products that are targeting these exascale platforms. And we're doing some new products as well. There are certainly some new ones, new opportunities for capabilities that haven't been around much, or maybe were nascent prior to ECP, and now we're trying to bring them in and make them full-scale capabilities. Okay, so that's a little bit of a background about ECP, and the reason I bring it up is that ECP is I think, a great project. It allows us to bring the efforts of many institutions together under a single leadership umbrella and a single funding umbrella that allows us to engage collaboratively in a very deep and consequential way across institutions, which have always collaborated. It's not like we're brand new in that way, but I think the degree of collaboration, the degree of coordination we can have is really first of a kind, at least in the US Department of Energy. And it allows us to do things at a scale that we haven't been able to think about before. And one of those is E4S. So E4S is the Extreme Scale Scientific Software Stack. You'll notice that the name does not say the Exascale Scientific Software Stack. We do not intend this to just be a one-time thing. We want this to be focused on leading edge capabilities indefinitely as we go forward. So DOE has always delivered high-value, reusable software products for HPC systems, including at the facilities that I mentioned. So that part's not new. What is really new is our ability, as I mentioned, that we have this now larger organizational structure, and so we can start to talk about aggregations of capabilities, in a sense, a portfolio approach to these software capabilities. The first level of that portfolio approach are what we call SDKs, software development kits. These are collections of similar types of products. So the first one was the Math Libraries SDK, we sometimes called the XSDK. It was around even before ECP, bringing together math software teams to make sure that their products are compatible version-wise and functionality-wise, interface-wise, but also to work on a set of community policies, expected behavior. If you're going to be part of this SDK, what are the expectations for quality, for user support, response? What licensing model do you have? Is it compatible with what other people are doing? So in essence, what these community policies end up becoming is entrance criteria, membership criteria for being part of the SDK. Through the SDKs, we're addressing and elevating quality of the products that we're producing, improving user experience by our interactions, and actually creating community. I remember at the early days of the Math Libraries SDK, the kind of mistrust that existed between teams. We heard about each other's rumors, and it was really quite interesting. I saved the emails because they're fascinating to me. But over time, we've come to trust and build upon each other's strengths and get to know each other as a community. And now we're trying to grow this in other areas. I'll show you in a bit what I mean by that. So that's the first level of integration and aggregation, these SDKs. To the user, at the first glance, maybe they're not so valuable, but they really do provide that quality experience, that improvement in quality. And we will see over time that these SDKs elevate the quality of the products to which these products belong to these SDKs. Then the high level aggregation is E4S itself. And E4S is essentially an HPC Linux distribution. But once you have this portfolio of Linux, HPC Linux capabilities, you can do all sorts of things with it. And Samir later today will show you in a demo, I believe, some of the things that can be done with E4S. But essentially, E4S is this HPC Linux distribution. We're also creating community policies. We're also creating testing capabilities and regularly testing and porting E4S to new platforms and managing versioning of this as new capabilities come in. So one way to think of E4S is, yes, it's an HPC Linux distribution. There are many. But the unique aspect, one of the unique aspects of E4S is the fact that it is the delivery vehicle for the latest exascale capabilities. This is where you're going to find the capabilities for the next generation platforms, because this is where ECP is putting them, and we hope others will join us in that effort. And of course, SPAC is a huge part of this. We'll hear a lot about SPAC as the day goes along. So what is E4S? It's a curated release of ECP products and everything that we depend upon. It provides container images and pre-built binaries and this binary cache, which you'll hear about, and a lot of other capabilities that are here. Cloud-based images. And so we're able to quite quickly start migrating our capabilities out to the various places where people want to use HPC software. All right, so we've had a number of releases, and as you can see from the list here, that we've continued to increase the number of products. ECP software technology supports contributions to roughly 70 software products. And so you can see from here, 50 of them are fully available, and then there are 10 that are in partial releases. The other 10 are newer efforts that aren't quite ready for SPAC build within the E4S portfolio. And this is just a list of the products that are a part of that. These slides will be available, and so you can see some details later. You can also go to the e4s.io website and get a lot of detail about the project. I wanted to mention a little bit more about SDK, software development kits. They are collections of like products that have similar domain scope, have similar interaction model. We want to create community policies. We want to create a meta infrastructure, for example, a SPAC target to be able to do a SPAC install of the XSDK, Math Libraries SDK, coordinated planning and coordinated community outreach. What's happened in the Math Libraries area where this is most advanced is tutorials are now done as a collection. We don't have a PETSI tutorial and a SuperLU tutorial and a Trilinos tutorial independently planned. We have an XSDK tutorial where coordinated delivery of content occurs. And we want to grow that. And in the Math Libraries area to continue it, and in other areas as well. Just to show you the progress in the Math Libraries area, we've gone from 5 in the original 0.1 release to 23. Also worth noticing is that this is not just DOE libraries. We have libraries that are primarily funded from the U.S. National Science Foundation, DL2, for example, and we have libraries that are coming from Europe. FIST, for example, comes out of the German aerospace DLR. And so we're incorporating products, and membership in these SDKs is simply showing, well, it might not be so simple depending on where you are in the status of your efforts, but it is being able to meet the community policy expectations that are part of the SDK. So one of the really important things I mentioned a little bit is this notion that the SDKs and E4S even more broadly provide what some people call addressing the dependency hell. You know, if you're an application team and you want to use functionality from other capabilities, then the challenge that you might face is that if you upgrade to a new version of one of the libraries, it may create incompatibilities for the other libraries, other things that you depend upon. And the SDKs regularly manage dependency and version changes by making sure that, you know, in this example, you know, Petsy has always managed its version of SuperLU, so it knows which version it uses. Trilinos does the same thing, but we've never before managed or coordinated which version of SuperLU each of them is using, so that we can be able to build both of Trilinos and Petsy within the same application. And this is the kind of thing that the SDKs provide, and then E4S more broadly. So the SDKs provide a kind of a refactoring of dependency management to a smaller scope, so it's easier to manage it at the local level and then take advantage of that dependency management at the higher level, at the E4S level. All right, just to show you some sense of what these policies are, I have the list here, and these are not unreasonable things. These are things that you would hope that a package or product would be able to satisfy. Some of them are a bit prescriptive. We're not allowing somebody to have just any ad hoc build system. You need to have something that is invocable from spec. It can't be a hand-tuned makefile, for example. Same thing for a test suite. User-provided MPI communicator is a best practice. If you're an embedded library, you can't just use MPI ComWorld, for example. And then this particular list is managed on a regular basis. New policies are being added, existing policies are being modified as new teams come in and they say, okay, I think I understand what you're trying to get at with this policy, but it's too narrow, too prescriptive for me. Could we consider something a little bit different? And so that actually refines. I saw Todd's comment, SPAC can handle hand-tuned makefiles. Okay, I stand corrected, although I'm wondering how you just pop it up then. And okay, that's an XSDK requirement. Anyway, okay, very good. So let me move on and get to other topics. Okay, packages can handle this by patching the makefile. Okay, fine. That's good point. Thank you, Todd. Okay, so I mentioned the XSDK. We've been now working and expanding this SDK model to the broader set of products that are funded or partially funded at least by ECP. And so we've been iterating through and trying to find what are some existing collections of packages that we can then pull together in these SDKs to create the same kind of set of policies and set of interoperability and versioning dependency hell management that we've been able to experience in the math libraries. And this is a snapshot of it. This is evolving as time goes on as well, but at least it gives you some sense of where we are and what kinds of aggregations we can create. So this is still in beta mode. We're not quite ready with these, but the teams in the SDK and the E4S effort have been working very diligently to come up with policies for E4S. So in other words, if you're going to be an official E4S package product, these are at least right now, and then over the next few weeks, we anticipate completing this list and publishing version 1.0 of the community policies for E4S. And SPAC build and install, minimal validation, sustainability, product metadata, and so on. These are, and then there's some text underneath I won't go into, but these are essentially, if you're going to become a full-fledged member of E4S, these are the minimal community policies that we expect you to address and provide evidence that you support. Note that these are versions. We don't expect that these policies are going to be immutable. In fact, you know, in a certain sense, we're trying to get them out the door so that we can exercise them and learn from what we have here already and try to improve upon them, so that via iteration and incrementation, we can have better, more effective, essential, but nothing more than essential policies for what it means to be part of E4S. And then you should also see additional, you know, refined policies for the SDKs, much like we have in the math libraries area. So we anticipate efforts. So I'm going to move along. Although I see here there's, let's see. Let me take a look, just at questions a little bit here. So it looks like some of them have been answered. Yes, the slides and recording will be available. Let's see, John Linford asked, are there regional exascale efforts planning to use the E4S, or could E4S be used as a starting point for future exascale software stacks? For example, Recon uses SPAC heavily and could theoretically pick up much of the work done here. I would hope, and this is my strong desire, is that E4S does not become, you know, a regional effort. I would love for us to be able to collaborate both across, you know, within the United States, across agencies, within, you know, with industry, and then also internationally. I personally think that as long as we can have a you know, a compatible vision, that everybody can contribute to the same software stack. That's my hope, and we're planning in the direction of, you know, bringing in other stakeholders who can help us, you know, form a vision for how we can all collaborate together of like-minded people. And so that is our intent as we go forward with E4S. All right, let me keep moving then. All right, and I just wanted to give you a bit of a glimpse. You know, these policies are not just about setting out some rules and expectations. They're actually community conversations. Yes, there are commitments to quality. Yes, there are membership criteria for the future. But I just show you just a screen capture of, you know, what's going on in real time right now with the SDK and E4S community policies. These are deep and passionate discussions about what it means to have high quality software. And so it often occurs in Google Doc conversations with sidebar comments, but the policies that are being developed are not just simply stated. These involve long and detailed conversations among the development teams, so that they make sure that what they're saying is the essential and nothing more, and is achievable. And so one of the great benefits of developing community policies is this community building aspect to it. And we have a lot of work to do, you know, by having policies. That's one thing, but then how do you determine if someone wants to join? What's that process for having them join? So far, we've done it very informally, even within the math libraries area. And we will need to try to formalize that, at least in some lightweight way, as we go forward. All right, I want to spend a little bit of time talking about one of the things I'm most excited about with E4S. Not that there's all sorts of great work going on, but from the portfolio perspective, one of the things I'm most interested in about is our DocPortal. And this is a lot of the work has been done by Wyatt Spear, his colleagues, and Samir Shendi in making real, you know, thoughts that we've had about how can we support our user community, you know, with lightweight aggregation of documentation. You know, and so over time, if you're an HPC user, software user, you know, all sorts of issues come up. You know, how do you find information for a specific product? You say you want to use a library, but you're not sure what license it has. Is it supported? How do I get a hold of somebody if I have questions? If you have a functionality need, how do you know how to find products? Now, Google does an okay job of finding things sometimes, but HPC is not one of those things that is high on the list, and you're going to have to go search typically through a lot of different pages to find what you want. And then how do you trust the accuracy of the information? How do you know it's up to date and complete? And then also, I think most users are looking for a hierarchical presentation of information. They want to see basics, and then maybe for some things, they want to dive a little bit deeper. And so what we've been trying to do is create something that addresses these basic needs. If you're a developer, you want to efficiently and effectively generate and maintain your documentation. If you're trying to provide something to an aggregator, you don't want to have to provide that in a repetitive, redundant way. You also want to get noticed by users. So one value proposition of a documentation portal like E4S is you can get noticed by new users. And then again, you want to be able to convey some summary information and then allow details to emerge as needed. So the E4S DocPortal, it provides a single online code location for accurate product descriptions. It's accurate in the sense that if there are inaccuracies, it's because the development teams themselves have not updated or provided accurate information. We rake information directly from the repositories. We may cache it if the link is down for a moment, but it's essentially information that comes from the development teams themselves. And then some of the derived requirements we have were sustainability, has to be incremental, and then extensible. So the basic design principles of the portal are all content resides in the product repositories. We use metadata files. We look for things like readme.md, the license file, contributing.md, and these are pseudo-standard names that many teams have picked up over time to convey metadata about the product. And then we access this information using a web raking tool, and all we need from you is a single URL. So the status of this effort is we've completed a prototype and design. We sent that out to our developer and stakeholder teams to get their feedback back. And then we've been able to create version 1.0 and it's available. You can go out now and take a look. Our next steps now are to work with the ST teams to improve the amount and quality of the rake content and develop policies and acceptance criteria for DocPortal membership. This page just shows you a screenshot of what you see if you go to the site right now. What's notable is there's a search bar. And so if you want to go look for something based on functionality or name, you can do that. Also, it is sortable by name, by area, by description, by other factors as we go along. Let's say you pick one of the products. I just picked Adios, for example. If you tap on Adios, then you see this is raked information, but then formatted for display on the E4S DocPortal site, so you can start to see some of the details. And then if you go and look on the home page, then you go directly to the detailed information about Adios. There's a question here that says, does DocPortal retain history of cached or mirror docs? That's a great question. We do not, as far as I know. Yeah, that's a great question. We should talk about that. Thank you. So anyway, so this gives you some sense of what's out there. This has always been a concern at the facilities. They want to know, you have these products, how can we find out more about them? How can we find out about the license model? Who can we contact to get support? And this particular site is attempting to provide that kind of information by giving you access to what the teams themselves are providing for. So it allows you to find the needles in the haystack by pulling them all together and pointing to them from one location. Once you get into, so how then do we support this? Well, if you go and look at, this is again all on the E4S project GitHub repository, the single bit of information we need from a team is the URL that points to one element of their repository. Then within that, what we look for are these metadata files. So the contributing.mp, the copyright, license, REME. and we find these files, and then we rate them for information. Of course, then there are protocols about how to name those files. We have some YAML syntax that allows a fair bit of flexibility in how you define, where this content lives. Maybe it's in a special folder underneath, so you don't want to, mess up your existing metadata files, but you still want to provide unique information to E4S. And so there's more than one way to provide the information that we're looking for. Okay, so the status is we've completed now, and it's available. And I mentioned already what we're trying to do as far as next steps. All right, so let me move along. So how do you access E4S software? From source in many other ways. Samir is going to talk about this later, so I won't go into a lot of detail. The key kind of hook is to go to e4s.io. That's really the start, because you can go there and then download, get access to capabilities to download and install from source, but also from container versions, and also find out about build cache capabilities too. I want to mention SPAC just a little bit. We're going to have a talk from Todd later today, but SPAC really is the backbone that makes E4S possible from a technology perspective. It's what we've used from the very beginning, and we're happy to see it to continue to gain traction in the broader community and to acquire new features that allow us to use it even more fully. And just to give you some sense, Samir provided these slides to me, and I appreciate that. So Nalu is a fluid structure interaction code that uses a lot of libraries. It's used in the Exawin project, a version of Nalu is, and it has a lot of different libraries. So you can see these are some of the dependencies. Another one is Deal2, I mentioned. It's a very diverse finite element library and uses a lot of third-party software. And then another code is RMiner, a data mining library, uses even more code. So we don't want to look at this and be afraid. We want to look at this and say, how do we address this? And so E4S and SPAC, the use of SPAC is how we're trying to address this. I just want to mention briefly the SPAC build cache that is being built up at the University of Oregon, E4S build cache, that as SPAC builds things, sees a signature, it can cache that build, and then if it sees that signature again in the future, it can go to the cache and grab it and dramatically reduce the build time with that. This is being used in a couple of settings now, probably more that I don't know about, but WDM is an ECP application where it's being used. And then also within Pantheon, and talking with David Rogers, one of the developers, is they're able to see by the use of the E4S binary caches. And can you hear me well? My internet is.
Yeah, we can hear you.
Okay, great. All right, just want to make sure. They're able to see a 10x improvement in speed, but in correspondence with him, he said it's actually closer to 100 when you consider all the snafus that they tend to run into with the old approach to building their products. And so the combination of SPAC certainly, and then E4S by providing the latest capabilities that are coming out of ECP is an incredible booster in productivity for them. I do need to mention that E4S builds on a lot of different and previous efforts. Now, we didn't emerge from nothing. HPC Linux worked on at the University of Oregon and at ParaTools, the math libraries, XSDK, and then of course SPAC predates E4S. And really I have to say all the useful open source software that's been created by the scientific community. We're leveraging and providing that value to users via this portfolio. All right, so just to summarize up just a couple more slides. I want to say what E4S is not. It's not a closed system taking contributions only from DOE. We really foresee the E4S to be a broad multinational and multi-agency software delivery portfolio. It's not monolithic, take it or leave it. It's a packetized approach to providing software capabilities and inserting your own functionality within it. It's not a commercial product. We are not trying to compete with vendors. In fact, what we're trying to provide in the case of vendors is a really solid starting point for them to provide their own value add to the HPC software community. And it's not just a simple packaging of existing software, in particular via the SDKs. And now as we bring online the community policies for E4S, we are asserting expectations on quality. And we expect teams to live up to, and if they're not already, to increase the quality of what they're trying to provide, and also help us define what quality means. This is a community conversation, and we need the community itself to articulate what value means. What's the essential expression of value? And just one more slide on collaboration models. If you're interested in working with us on the E4S project, certainly you can use E4S containers for tutorials and webinars. We have a number of people who do that. It's a very effective way of providing an HPC Linux environment. You can evaluate our new capabilities. You'll see some of the very first usable exascale software, pre-exascale software in E4S. You can install E4S. We want to explore how to make this possible. There are a lot of different ways to do it. And then you can contribute to E4S and the SDKs. If you have a product that fits into one of the SDKs, please communicate with us. We would love to talk with you. And then overall, we want full collaborative interactions that we think benefit everyone. All right, a little bit of a summary. So what is E4S and the SDKs? It's the latest ECP developed features right now for 50 products or so. Ported and validated regularly to all common and emerging platforms. We're preparing now for the early access systems that are online, that are leading up to the exascale platform. We provide the single DocPortal access with collaborative development communities around the SDKs, quality expectations through the policies, and then many different access modes for getting the software itself. E4S is a new member of the HPC ecosystem, and to me, this is one of the most exciting things about it. We are having first-of-a-kind conversations with vendors, with facilities, with other agencies, industry, and internationally, because rather than being just a whole bunch of disparate, independent projects that are smaller teams, there's a size mismatch. If the MPI-CH team wants to go talk to OLCF, that doesn't make so much sense. What does make sense is if the E4S team talks to Oak Ridge Leadership Computing Facility. That's a peer-to-peer conversation. And those conversations are occurring in ways that we haven't seen before. The other thing is that this is not just unique to today's current HPC needs. This is fully extensible. You do not need to change fundamentally anything in order to include HPC software in AI and ML. And it is a new way of delivering reusable HPC software with improving quality and functionality, and we would welcome your interactions in this endeavor. The last thing I just want to mention, as this work is part of ECP, we put out a report about twice a year called our capability assessment report. The reason why I bring it up is that version 2.5 we're working on right now will have a refresh of the write-ups on the product, and it'll be a foreshadowing of the next set of ECP features that are going to go into E4S, and we're scheduling that for the middle of November. And I'll stop here and take any questions if there are some. Right, my phone rebooted, so let me see if there are some questions here. Oh, looks like we've been able to keep up what the questions are there. So any other questions, either verbally or in chat? All right, very good. Well, I think we have a few minutes, right, Samir, before the next presentation starts?
Yes, we can take a